Section 1. One Group Designs. The learning objectives for this section are 1. Explain what quasi-experimental research is and distinguish it clearly from both experimental and correlational research. 2. Describe 3 different types of one-group quasi-experimental designs. 3. Identify the threats to internal validity associated with each of these designs. One-group post-test only design. In a one-group post-test only design, a treatment is implemented, or an independent variable is manipulated, and then a dependent variable is measured once after the treatment is implemented. Imagine, for example, a researcher who is interested in the effectiveness of an anti-drug education program on elementary school students' attitudes towards illegal drugs. The researcher could implement the anti-drug program, and then immediately after the program ends, the researcher could measure students' attitudes towards illegal drugs. This is the weakest type of quasi-experimental design. A major limitation to this design is the lack of a control or comparison group. There's no way to determine what the attitudes of these students would have been if they hadn't completed the anti-drug program. Despite this major limitation, results from this design are frequently reported in the media and are often misinterpreted by the general population. For instance, advertisers might claim that 80% of women noticed their skin looked brighter after using brand X cleanser for a month. If there's no comparison group, however, then this statistic means little to nothing. One group pre-test post-test design. In a one-group pre-test post-test design, the dependent variable is measured once before the treatment is implemented and once after it's implemented. Let's return to the example of a researcher who's interested in the effectiveness of an anti-drug education program on elementary school students' attitudes towards illegal drugs. The researcher could measure the attitudes of students at a particular elementary school during 1 week, implement the anti-drug program during the next week, and finally measure their attitudes again the following week. The pre-test post-test design is much like a within subjects experiment in which each participant is tested first under the control condition and then under the treatment condition. It's unlike a within subjects experiment, however, in that the order of conditions is not counterbalanced because typically it's not possible for a participant to be tested in the treatment condition first and then in an untreated control condition. If the average post-test score is better than the average pre-test score, for example, attitudes towards illegal drugs are more negative after the anti-drug education program, then it makes sense to conclude that the treatment might be responsible for the improvement. Unfortunately, one often cannot conclude this with a high degree of certainty because there may be other explanations for why the post-test scores may have changed. These alternative explanations pose threats to internal validity. So remember, internal validity is knowing that or being confident that the independent variable caused some change in the dependent variable. An acronym that can be useful for remembering the types of threats to internal validity is Mrs. Smith. So this section will cover some of them and we'll cover the rest in class. One alternative explanation goes under the name of history. Other things might have happened between the pre-test and the post-test that caused a change from pre-test to post-test. Perhaps an anti-drug program aired on TV and many of the students watched it. Or perhaps a celebrity died of a drug overdose and many of the students heard about it. Another alternative explanation goes under the name of maturation. Participants might have changed between the pre-test and the post-test in ways that they were going to anyway because they're growing and learning. If it were a year-long anti-drug program, participants might become less impulsive or better reasoners, and this might be responsible for the change in their attitudes towards illegal drugs. Another threat to the internal validity of one group pre-test, post-test designs is testing, which refers to when the act of measuring the dependent variable during the pre-test affects participants' responses at the post-test. For example, completing the measure of attitudes towards illegal drugs may have had an effect on those attitudes. Simply completing the measure may have inspired further thinking and conversations about illegal drugs that then produced a change in the post test scores. Similarly, instrumentation can be a threat to the internal validity of studies using this design. Instrumentation refers to when the basic characteristics of the measuring instrument change over time. When human observers are used to measure behavior, they may over time gain skill, or become fatigued, or just change the standards on which observations are based. So, participants may have taken the measure of attitudes towards illegal drugs very seriously during the pretest when it was novel, but then they may have become bored with the measure at post-test and been less careful in considering their responses. Another alternative explanation for a change in the dependent variable in a pretest post-test design is regression to the mean. This refers to the statistical fact that an individual who scores extremely high or extremely low on a variable on one occasion will tend to score less extremely on the next occasion. For example, a bowler with a long-term average of 150 who suddenly bowls a 220 will almost certainly score lower in the next game. Her score will regress toward her mean score of 150. Regression to the mean can be a problem when participants are selected for further study because of their extreme scores. So imagine, for example, that only the students who scored especially high on the test of attitudes towards illegal drugs, meaning those who had extremely favorable attitudes towards drugs, maybe only they were given the anti-drug program and then they were retested. Regression to the mean all but guarantees that their scores will be lower at post-test, even if the training program had no effect. A closely related concept to this, and an extremely important one in psychological research, is spontaneous remission. This is the tendency for many medical and psychological problems to improve over time without any form of treatment. The common cold is a good example. If one were to measure symptom severity in 100 common cold sufferers today, give them a bowl of chicken soup every day, and then measure their symptom severity again in a week, they would probably be much improved. This doesn't mean that the chicken soup was responsible for the improvement, however, because they would have been much improved without any treatment at all. The same is true of many psychological problems. A group of severely depressed people today is likely to be less depressed on average in 6 months. In reviewing the results of several studies of treatments for depression, researchers Michael Posternak and Ivan Miller found that participants in waitlist control conditions improved an average of 10 to 15% before they received any treatment at all. Thus, one must be generally very cautious about inferring causality from pretest post-test designs. A common approach to ruling out the threats to internal validity described previously is by revisiting the research design to include a control group, one that doesn't receive the treatment effect. A control group would be subject to the same threats from history, maturation testing, instrumentation, regression to the mean, and spontaneous remission, and so would allow the researcher to measure the actual effect of the treatment if there is any. Of course, including a control group would mean that this is no longer a one-group design. Does psychotherapy work? Early studies on the effectiveness of psychotherapy tended to use pre-test post-test designs. In a classic 1952 article, you can see on the screen, researcher Hans Eisnick summarized the results of 24 such studies, showing that about 2/3 of patients improved between the pre-test and the post-test. But Eisnick also compared these results with archival data from state hospital and insurance company records, showing that similar patients recovered at about the same rate without receiving psychotherapy. This parallel suggested to Eisnick that the improvement that patients showed in the pre-test post-test studies might be no more than spontaneous remission. Note that Eisnick did not conclude that psychotherapy was ineffective. He merely concluded that there was no evidence that it was, and he wrote of the, quote, necessity of properly planned and executed experimental studies into this important field. You can read the entire article online. Fortunately, Many other researchers took up Eisnick's challenge, and by 1980, hundreds of experiments had been conducted in which participants were randomly assigned to treatment and control conditions, and the results were summarized in a classic book by Mary Lee Smith, Jean Glass, and Thomas Miller. They found that overall psychotherapy was quite effective, with about 80% of treatment participants improving more than the average control participant. Subsequent research has focused more on the conditions under which different types of psychotherapy are more or less effective. Interrupted time series design. A variant of the pre-test post-test design is the interrupted time series design. A time series is a set of measurements taken at intervals over a period of time. For example, a manufacturing company might measure its workers' productivity each week for a year. In an interrupted time series design, a time series like this one is interrupted by a treatment. In one classic example, the treatment was the reduction of work shifts in a factory from 10-hour shifts to 8-hour shifts. Because productivity increased rather quickly after the shortening of the work shifts, and because it remained elevated for many months afterward, the researcher concluded that the shortening of the shifts caused the increase in productivity. Notice that the interrupted time series design is like a pre-test post-test design in that it includes measurements of the dependent variable both before and after the treatment. It's unlike the pre-test post-test design, however, in that it includes multiple pre-test and multiple post-test measurements. Figure 8.1 shows data from a hypothetical interrupted time series design. The dependent variable on the y-axis is the number of student absences per week in a research methods course. The treatment is that the instructor begins publicly taking attendance each day so that students know that the instructor is aware of who's present and who's absent. The top panel shows how the data might look if the treatment worked. There's a consistently higher number of absences before the treatment, and there's an immediate and sustained drop in absences after the treatment. The bottom panel shows how the data might look if the treatment did not work. On average, the number of absences after the treatment is about the same as the number before. This figure also illustrates an advantage of the interrupted time series design over a simpler pre-test post-test design. If there had been only one measurement of absences before the treatment at week 7 and one afterward at week 8, then it would have looked as if the treatment were responsible for the reduction. The multiple measurements both before and after the treatment suggest that the reduction between week 7 and week 8 is really nothing more than normal week-to-week variation.